inverse matrices. This is our last method that we're learning of how to solve a system of equations using matrices. So we've already looked at reduced row echelon form and Kramer's rule, and now we're going to look at inverse matrices. So before we get into the matrices part, I just wanted to talk to you for a minute about inverse operations and identities. So if you think of multiplication, some number A, whatever this is, you say, hey, there's something called an identity for multiplication. You say, what is it I can multiply any number by, and it doesn't change who it is. I can multiply any number by the number 1, and it doesn't change its identity. 1 is the identity for multiplication. All right, if we have one for addition too, what number can you add to any number and it doesn't change who it is, who's its identity? For addition, if you have some number A, you can add 0 to it and it doesn't change its identity. Okay, this is identity for multiplication. 1 is the identity for multiplication. Okay, and 0 is the identity for addition. All right. But then we have something that we say inverses. What could I multiply a number by in order to get the identity 1? What could I multiply A by in order to get 1? Well, I multiply it by its multiplicative inverse or its reciprocal. 1 over A. This is the inverse of A, the multiplicative inverse of A. Multiplicative inverse of A. All right, well, we have one for addition. You say, what could I add to a number to get the identity 0? A plus what gives me 0? Well, the opposite of A, negative A. So this is the additive inverse. Okay, this is number world. Let's go to matrix world. We do have an identity matrix. We do have an inverse matrix. So let's look at how those work now that we remember what these concepts are. So if we have some matrix, and it has to be a square matrix that these deal with. We don't have an inverse matrix or an identity matrix for a matrix that's not square. But for a square matrix, let's just, if you have a square matrix, it has an identity. And so on your sheet, I've written down some identity. The identity for a 1 by 1 is a matrix, a 1 by 1 matrix with the number 1 in it. For a 2 by 2, 2 rows, 2 columns, it looks like what we see when we have the reduced row echelon form of a matrix, right? And so for a 3 by 3 and so on, the identity matrix would be 1, 1, 1's on the diagonal and 0's everywhere else. And this goes on and on and on. So just to show you how this works, if I'm making up this matrix now, 1, 2, 3, 4. All right, very boring, but it will serve. Let's take A and let's multiply it by a 4 by 4, a 2 by 2 identity. So if you recall matrix multiplication, size of A is 2 by 2. The size of the identity is 2 by 2. The inner dimensions match, okay, and it's going to result in the outer dimensions, which is a 2 by 2. So let's multiply, ready? Row 1 by column 1. 1 times 1 is 1, plus 2 times 0 is 0. 1 plus 0 is a 1, all right? Row 1, column 2. 1 times 0 is 0, plus 2 times 1 is 2. Okay, row 2, column 1 to get this guy. 3 times 1 is 3, plus 4 times 0 is 3. Okay, row 2, column 2. Row 2, column 2. 3 times 0 is 0, plus 4 times 1 is 4. When we multiplied A times the identity matrix, we got A again. That's how that works. Now, there is an inverse matrix that we could take A and we can multiply it by A inverse, and we will get back the identity matrix. That's true. So here is the theory find solving a system of equations using an inverse matrix. Suppose we have a system of equations and we write the matrix equation. AX equals 2B. If we multiply both sides of this equation by A inverse, because remember we're solving for X, we're solving for X. So if we multiply both sides of this equation by A inverse times A is equal to A inverse times B, right? We have to, well, we multiply on one side, we have to multiply on the other. Okay. But what's happening here? A inverse times A is just the identity. All right, so this is just the identity matrix times X. All right. But if we take the identity matrix and multiply it by anything, it doesn't change its identity. That is who it is, right? 1 times A is A. 1 times X is X. So we just get X here. So X is equal to A inverse times B. So here's the gist of the story. If you are asked to solve a system of equations using an inverse matrix, you should multiply the inverse of the coefficient matrix times the solutions matrix B. That's how you do it. So let's do one, okay? I'm going to do number 1. First, I'm going to find A inverse showing you how it's done mechanically. People did it by hand. I'm going to do it by hand, how your calculators figure it out. And then I'm going to show you a little formula you can do for a 2 by 2. Okay. You do not have to do it by hand, okay? You may use your calculator for all of the finding an inverse, okay? But I do want fractions, and so we'll make sure we know how to do that. Let's solve this equation using A inverse. So here's the moral of the story. How do you solve? You find A inverse and you multiply it times B. So here, number 1, we're just practicing finding A inverse. So let's do it. A is 3, 1, negative 2, 5. Okay. So if you didn't have a calculator and you needed to find the inverse, this is, or if you're taking a linear algebra course and they're like, you can't use your calculator, you have to appreciate how to do this. What you would do to find the inverse is augment this matrix with the identity matrix of the same size. All right, then you would use those 3-row operations that we looked at earlier in our REF and use those over and over again until you can make the identity matrix appear over here, and whatever appears over here is A inverse. So I'm about to do that. You do not have to do this, but it's kind of interesting. One of the row operations says that I'm allowed to interchange any rows, and I like to start with a 1 there if I can possibly get it. So I'm going to interchange these 2 rows. So that's going to look like this. 1, 5, 0, 1 is in the top, 3, negative 2, 1, 0 is then down here. Now, I would like to zero out this because I'm trying to make it look like this. So I'm going to multiply this first row by negative 3 and add it to the second row. This is another operation. So if I take 1 times negative 3, that's a negative 3. 5 times negative 3 is negative 15. 0 times negative 3 is 0. 1 times negative 3 is negative 3. So in my next step, I'm keeping the first row, 1, 5, 0, 1. I just borrowed him. I multiplied him by something. I'm going to add it to the second to change this one. Negative 3 plus 3 is 0. Negative 15 plus negative 2 is negative 17. 0 plus 1 is 1. Negative 3 plus 0 is negative 3. Okay, we're getting closer. Now, I would like a 1 right here. So what I'm going to do is go through and I'm going to multiply this whole row by negative 1 over 17. That looks like this. 1, 5, 0, 1. I didn't change the top first row. The bottom row is going to be 0, 1. 1 divided by negative 17. Negative 3 over negative 17 is 3 over 17. All right. Now, what I want to do is multiply. I want a 0 right here, and I'm done. I'm going to borrow the bottom row again. I'm going to multiply the bottom row by negative 5, and then I'm going to add it to the top row. 0 times negative 5 is 0. 1 times negative 5 is negative 5. Negative 5 times negative 1 over 17 is 5 over 17. Negative 5 times 3 over 17 is negative 15 over 17. Okay, so finally, what I'm going to get here is 0 plus 1 is 1. Negative 5 plus 5 is 0. 5 over 17 plus 0 is 5 over 17. Negative 15 over 17 plus 1 is going to be 2 over 17. 0, 1, negative 1 over 17, 3 over 17. Okay, I finally got the identity right here, and what this is A inverse. All right, so let's make sure it's A inverse. This is how you can make sure. Take A inverse, what I think A inverse is, and multiply it by A, and I should get the identity matrix. So, if I take 5 over 17, 2 over 17, negative 1 over 17, and 3 over 17. All right, and I multiply it by A, 3, 1, negative 2, 5, I should get the identity matrix. And if I don't, I've made a math error. So let's see what happens here. 3 times 5 over 17 is 15 over 17, plus 2 over 17 times 1 is 2 over 17. 15 plus 2 is 17 over 17, or a 1 goes right there. Excellent. Let's go for this spot right here. Row 1, column 2. Negative 2 times 5 over 17 is negative 10 over 17. 2 times 5 is plus a 10 over 17. Negative 10 plus 10 is a 0 is what's going right there. All right, now let's go for this spot. I'm going to multiply row 2 by column 1. 3 times negative 1 over 17 is negative 3 over 17. Plus 1 times 3 over 17 is 3 over 17. This plus this gives me a 0 right there. And so row 2, column 2, negative 2 times 1 over 17 is 2 over 17. Plus 5 times 3 is 15 over 17. 15 plus 2 is 17 over 17, which is a 1. Okay, you do not have to do all this, but it's kind of interesting to see where it comes from. There is a formula for a 2 by 2 matrix. There's not for other ones that tells you how to find this. Okay, and it's on your sheet. So basically what it says is if you've got a 2 by 2 matrix and you need to find the identity, you can just do this. You can just do this. If you've got some A, and let me just write things in position, A, B, C, D. A inverse is equal to 1 over the determinant of A times this matrix. You switch A and D. D goes here, A goes here, and you just negate these terms, and this is the inverse. So let's just find it for this one. All right, what is A? Let's find the determinant of A. Okay, that's going to be 3 times 5 is 15. 1 over that, okay. Minus, wait, am I missing a negative here? No, AD over BC, okay. AD, 15 minus a negative 2 is plus 2. Okay, so we get this times, let's switch these positions, these switch, so it's 5 here and 3 here. And this becomes a negative 1, and this becomes a positive 2. All right, so 1 over 15 plus 2 is really 1 over 17. That's where that 17 is coming from. If I multiply a scalar times a matrix, it just gets multiplied times every element. So it's 5 over 17, 2 over 17, negative 1 over 17, and 3 over 17. Did that work out okay? Yes, it did. So this is how you can find an inverse of a 2 by 2. Again, you can use your calculator, but you have to write it in fractions. That's the only thing I insist on. Okay, so let's do number 2, and then I'll cut this to a second video. Number 2, rewrite the given system of equations into a matrix equation, then solve using an inverse matrix. So, I will show you how to use your calculator to find an inverse matrix on number 3, because it's so big. All right, so number 2 says solve this system. 2x minus 3y is a 9. And negative 5x plus 7y is an 8. So we're supposed to solve this using inverse matrices. Write the matrix equation. 2, negative 5, negative 3, 7. X, Y, 9, 8. Okay. When you use an inverse matrix, the solutions matrix, X, is equal to A inverse times B. So I will have you write down this. XY is equal to A inverse times B. And you need to know that this is B, and A inverse is what we're gonna figure this out right here, okay? I'll just do this one by hand because it's a little bitty 2 by 2. So it's gonna be 1 over the determinant, 14 minus 15 times, switch these places, 7, 2, make these the opposite signs. Okay, this is A inverse. So this is gonna be 1 over negative 1, basically. Times 7, 5, 3, 2, or basically a negative 1 times all this. So A inverse is going to be 7, 5, 3, 2. All right. That's A inverse. 7, 5, 3, 2. Now, I'll just tell you how to do this in a minute. I have my calculator out. If you wanted to find the inverse, not by any of these methods, but with your calculator, that's fine. Go to second matrix, enter a 2 by 2 matrix, enter this 2 by 2 matrix right there. Then hit second quit. Then hit X raised to the negative 1. It's a little bitty button on the left. It's not even a second one. It's just X negative 1. It's a little button like this. Hit that, and the inverse matrix will appear. If it's not whole numbers, I'm going to say write it in fractions, hit math, enter, and it'll do fractions for you. So you should be able to find this inverse matrix just by entering the coefficient matrix and then hitting this button. All right, so I'm going to multiply this by hand. You can use your calculator, it's fine. This is going to end up being 7 times 9 is 63 plus 24. That is a 7. That is an 87. Am I missing a negative 1? Did I forget the negative? Yeah, I got all excited and I forgot to multiply this whole thing by negative 1. This is really what it should be, sorry. So that's going to be negative 63 minus 24 is negative 87. All right, and then down here it's going to be negative 45 minus 16, 11, 4, 5, 6. Is that right? Yep, negative 61. So that's the solution for that one. Okay.